Hello, welcome. My name is Qcal. I am a student of planning and GIS, and on this channel, I talk about how to do mapping with ArcGIS, QCal and ArcGIS Pro. So if you are interested in this topic, kindly subscribe to this channel, hit on the bell icon, and like this video. Thank you very much. Okay, so in today's video, we are going to learn how to calculate or create land surface temperature map with Landsat 8.9. My previous video focused on how to do land surface temperature map with Landsat 7, and you can check that video out. This video focuses on how to do it with Landsat 8.9. And with the Landsat 8.9, we are going to do it with the Landsat Collection 2 Level 1. Yes. So we have Landsat Collection 2 Level 2, Landsat Collection 2 Level 1. This one will be for Landsat Collection 2 Level 1. And we are going to go through a series of steps. If you watch the Landsat 7.1, you could see that we went through the same steps. Yes. And if you want to know how to download Landsat images for analysis like this, NDVI, NDMI, land use land cover map, land surface temperature, you can check this video out. That video will take you through. So the requirements for this is that we need a band 10, band 5 and band 4 and the MLT text file. So when you download the bands, you have the MLT text file. The video I spoke about will take you through. So I have the 4 and I have dragged the bands in ArcGIS and I am having the MLT text. We are going to use some information from here to do the mapping. So now let's go. Once your bands are ready, you go to Arc2 box, you go to Spatial Analyst 2, this one, then you go to Map Algebra, Raster Calculator. The first formula is that you calculate TOA, Top-of-Atmospheric Radiance. The formula is ML times Qcal plus AL, and ML is radiance multiplicative band 10. We will get it from here. Radiance multiplicative band 10. This is it, and it is written as this. So you copy it and you bring it. The /04 you see means 0.000. So you write that, you remove this point, then you remove this. Do you get it? So you are going to turn this into a decimal figure, 0.000. Are you getting it? Yes. So when you are done, then the next one is that the Qcal. The Qcal is band 10, the raw band 10. This is it. So you are going to multiply the band 10 with this. So you go there, multiply by, this is the band 10. Are you getting it? So once we have the band 10, the next one is that AL. What is AL? AL is radiance add band 10, and we can also get it from the radiance add of band 10. It is 0 points, so you copy it plus this. Do you get it? So we are done with it. This multiply by band 10 plus this. If you like, you can specify where you want to save it, but for the sake of time, I'll click OK. So we've calculated the TOA, so I can just come here, TOA, and let's do this quick. They are too long, so I'll just hover the mouse on it and just reduce it to band 10. Do the same for this. The next step is that we need to calculate, some are having a formula of, here they will multiply, they will subtract 0.029 from it, and for that one we don't do that with collection 2. Yes, so here we are not going to add it. That is why you didn't see me adding it. Are you getting it? We are not going to subtract it from it. We don't do it with collection 2. So let's move on. So there's step 2. We will calculate BT, top of atmosphere brightness temperature, and the formula is bracket open. You open a bracket open K2. So what is K2 constant? We'll get it from here. When you come here, K2 constant of band 10 is this. You copy it. K2 constant divided by ln. divided by, so the ln is a conditional over here. This is it. A bracket will open. ln k1. So you go for k1 constant for band 10, which is this. You copy it. K1. It is K1 divided by, do you get it? K1 divided by LA. What is it? So the LA is actually the TOA we calculated in first step. This LA. Do you get it? K1 divided by LA, which is the TOA plus 1. Have you gotten it? Plus 1. Then the bracket will be double. You come here outside the bracket minus 273.15. Are you getting it? So K2 in bracket K2 divided by ln K1 divided by TOA plus 1 minus this. Are you getting it? The result will be degrees Celsius. So when we come here, we can specify where you want to save it. But for the sake of time, I'll click OK. Then I'll name it BT. We are done with step 2. Step 3, we are going to calculate NDVI. Do you get it? So for NDVI, the formula is float B5 minus B4 divided by float B5 plus B4. So fast forward, we go there. Float B5 minus B4 divided by another float B5 plus B4. Okay. NDVI is here. Do you get it? Yeah, so I have a video about NDVI that I went in depth and explained it very well. You can check that video out. So the NDVI is here, and if NDVI is here, you can just go there. NDVI. Do you get it? The next step is that we need to calculate for PV, proportion of vegetation, and the formula is square. You open a square. This is the conditional. Square. So the square, the brackets are double. NDVI minus NDVI minimum. This is what they are saying. The brackets are double. The NDVI we just calculated minus NDVI minimum. This, the low NDVI value. It is a negative value. So NDVI minus negative value. Do you get it? Then bracket close divided by bracket open. NDVI maximum minus NDVI minimum. Do you get it? This NDVI maximum minus this. So already I have the minimum, so I'll paste it there. Create a space for the maximum. So it will be this minus this. Do you get it? So at the end of the day, it is going to be nega po, NDVI plus NDVI maximum plus. Do you get it? But you can just leave it like that. The machine will actually deal with that. So do you get it? NDVI minus NDVI minimum. NDVI maximum minus NDVI minimum. That is the formula. Then you click OK. So PV is also here. So we will go to the next step, which is E, land surface emissivity, and the formula is 0.004 multiplied by the PV. 0.004 multiplied by PV. I didn't write the PV on it, so let me hover and write PV. So this multiplied by PV plus this. Do you get it? Plus this. That is E. You click OK. So this is E. So at the last step, we are going to calculate the land surface temperature. So the formula is BT. The BT we calculated in the second step. BT divided by bracket open. Divided by bracket open. 1 plus bracket open, 1 plus bracket open, y times bt. What is y? The y over here is actually effective wavelength of band 10 emitted radiance, which is this. Do you get it? So you copy it. It's a constant. Don't worry about it. So you paste that one there. Times bt times bt again. Do you get it? After that, divided by C2. Divided by C2. What is C2? C2 is actually this Planck's second radiance constant. Do you get it? After that, the bracket is closed. Do you get it? Times ln. This is the ln. Into it is E. Do you get it? And the bracket is double over here. Are you getting it? Yes. You see that there was a red sign here. If your formula is not right, it will be there to prompt you. So this is the formula we are having for the land surface temperature. BT divided by 1 plus this constant, which is y, times BT divided by C2. Do you get it? So let's click OK. So we are having the land surface temperature. We go here and look for our study area. My study area is Ejiso. So I'll drag Ejiso. This is Ejiso. Do you get it? So this is the LST. Let me name it LST, land surface temperature, and uncheck all these. Do you get it? So I'll go to search. Clip is there. I'll search for clip data management, select LST, select the boundary, check the 2 and click OK. So this is what I am having. So the highest value is 33 degrees Celsius and the lowest value is 24. Do you get it? In that year, and the year I am using is 2015. Okay, so LST Ejiso. Do you get it? So I can also go there, classified, maybe into 3, and choose this. So these are the highest temperature zones, these are the lowest temperature zones. Do you get it? Layout view. So you can add your scale, your legend, and other stuffs in here. Are you getting it? Yes. So this is how we calculate land surface temperature with Landsat 7 collection 2 level 1. I will do another video on how to do it with Landsat collection 2 level 2, of which you won't go through 6 steps but just a single step, then you are done. Yes. So thank you very much for watching, and I would like to see you in my next video. Bye bye.